Hello everyone, I am Ha-Ying Che from Institute of Data Science and Knowledge Engineering, School of Computer Science in Beijing Institute of Technology. In this session, we discuss stream computing model. The data processing system provides big data computing and processing capabilities and an application development platform. From the perspective of computing architecture, the data processing system is divided into data algorithm layer, computing model layer, computing platform and engine layer, etc. Computing models are the way that different kinds of big data is processed in different scenarios, which include batch processing, stream computing, large-scale concurrent processing, like MPP model for structured data, in-memory computing model, and data flow graph models. Now let's look at the stream computing model represented by STORM. Stream computing is a computing model that processes real-time dynamic data. The traditional enterprise database stores historical data, that is static data. That is, all data must be entered into the database before calculation and processing. Technicians can query and update the database and use data mining and OLAP analysis tools to extract static data from the database, find valuable information to support business decision analysis. However, in Internet applications like user web click tracking, online real-time recommendation system, etc., intelligent transportation system, wireless sensor network monitoring, and other fields, its data generation method and data characteristics have the following characteristics and calculation requirements. First one, data is no longer arriving in batches, but continuously arriving dynamically. Second, computational analysis require real-time, fast response, and low latency. The third, the amount of data is large, but the storage of the data is not valued. But the immediate processing and analysis of the data are emphasized. The fourth, pay attention to the calculation and analysis result of the data as a whole, but not to pay attention to the individual data. The fifth is the order and timing of the arrival of the data elements cannot be predicted or controlled, and the calculation program must be able to respond. MapReduce performs offline batch calculations for static data that has entered the database, and the calculations results are also stored in the static database. While stream computing is real-time analysis and the calculations for dynamic continuous data streams. After the calculation results are obtained, the data is either imported into the static database, either discard, that is one-time use. To support this data flow calculation mode, the flow calculation framework generally includes 3 steps: real-time data collection, real-time data calculation, and real-time data query service. Directed acyclic graph, DAG, is commonly used in distributed systems to characterize the calculation process or calculation model. The figure shows the combination of chained tasks in a distributed system. The node in different color in the figure represent computing tasks or computing objects at different stages. The one-way arrow indicates the order of the calculation steps and the dependencies. STORM is a native stream processing system. That is, the processing of stream data is based on each piece of data, and its parallel calculation is implemented based on a directed topology graph. Topology composed of spot, data source, and bolt, processing unit. Topology defines the logical model or abstract model of parallel computing, that is, designs of the calculation steps and processes from the perspective of function and architecture. The output of the spot is a series of tuple stream, and the input and output of bolt is also a series of tuples streams. STORM's computing system also adopts a master-slave architecture. There are mainly two types of node, master node and slave node. A Nimbus daemon runs on the master node like Hadoop's job tracker, responsible for task distribution and fault monitoring of the cluster. Nimbus manages many worker nodes through a group of zookeepers. Each worker node runs a supervisor daemon, monitors the status of the local node, and starts and shuts down the worker process of the node when necessary according to the Nimbus instructions. There are two ways of stream computing: native stream processing system represented by STORM, and microbatch stream processing system represented by Spark. Microbatch processing is the practice of collecting data in small groups, that is, batches, for the purpose of taking action on that data. Compared with native stream processing system, microbatch processing is not really real-time processing, but nearly real-time processing. It can save the computing cost because it waits until the microbatch composed. Contrast this to traditional batch processing, which often implies taking action on a large group of data. Microbatch processing is a variant of traditional batch processing in that the data processing occurs more frequently so that a smaller group of new data are processed. In both microbatch processing and traditional batch processing, data is collected based on a predetermined threshold or frequency before any processing occurs. During the real application, sometimes the batch computing and the stream computing combined to finish the history records analysis and real-time analysis, like showed in the diagram. Kafka broker take the data from the data producer and deliver them into stream computing STORM cluster and the batch computing Hadoop cluster. The processing output of STORM can be stored in NoSQL Cassandra database. The output of batch processing can be stored in HBase. After the data has been processed, the data analytics like virtualization, decision-making, prediction, OLAP, and recommendation can be done based on the result of batch processing and stream processing. In this session, we learned stream computing represented by STORM. Thank you for your attention. If you have any question, feel free to contact me.